Hello, a new tool on bionicchaos.com. There's a link to it on the main page. It's called EEG cross coherence function. When you load it, you get some ads to advertise with Google ads. So Google advertising Google. This is what the tool looks like. Again, as per usual, you can scroll through data. This is intracranial data from EEG.org. You can select your channels. This is 8 implanted electrodes on the left, right of the head, and 8 on the right. So number 0 and 7 will be the first electrode on each hemisphere. You can select different electrodes if you want. Change your window size. I just use 2 at the moment, just not to overload my server. And when scrolling through the data, you can see how the cross coherence function over here is changing. And it will also show you the FFT, the frequency response of each channel that you have selected. So just trying to find. So when you have a negative peak like this, it means that the channels are having similar components but 180 degrees out of phase. This is what happens, for example, you get a very large positive peak when you correlate the channel with itself, just as a sanity check. So in this case, again, you have this negative peak. Maybe we'll increase the window a bit, just so we can find something more useful. You can see that drop there. That should result in a positive peak here, but there's other things happening as well. This negative peak means, again, negative correlation, but also out of phase. So whatever you see on one channel is supposedly repeated on the other, but with a phase shift. This one, again, a large negative correlation. But don't actually see it here. This is what happens when you turn the trending on and off. So it will correct for DC and any low frequency components. Yeah, this channel tends to be always quite noisy, but you can see, for example, this tool allows you to check that there's actually no correlation between that noise on these two different channels. So maybe another channel. So if you see a large peak in here, that means that there is correlation like this. We'll just correlate it to itself. Something potentially there. So whatever is hard to see in time series or frequency domain can then be discovered using a cross coherence function, which is cross correlation between the two channels in frequency domain. See if we can find something else. Again, that channel is quite noisy, so select something else. Yeah, so in this case, you see this dip, and it's happening on both channels with about 18 Hertz phase difference. And same here, so that peak 26 Hertz difference, I guess it's this one here, happening on both channels, but delayed over time. Yeah, you have that peak there, it's almost happening at the same time, but not quite. Yeah, this one shows 4 Hertz phase difference correlation, large peak there. So the two channels essentially have the same features. Yeah, you can see it more clearly there. You have this large peak, 26 Hertz. Yeah, so your window size makes a lot of a difference. Oh, there was a high correlation there as well. Yeah, this one. I don't know what's happening there. There's a peak here. There's obviously some correlation there. You see same peaks in the FFT, but yes, there's a lot to untangle there because some things are actually different. And this is two hemispheres, so potentially this is some sort of artifact there. And you can also see what difference it makes between the different channels. So some will be more correlated to one another than others. So play around with this, tell me what you think. If you find any bugs, let me know. And I'll see you in the next video. Bye.